This is Purdue Math 162, Spring of 2020, Exam 1, Question 1. Sphere is described by this equation. What's the radius? We're going to move variables to the same side. 2x squared minus 8x plus 2y squared plus 12y plus 2z squared equals 2. Everything's even, so we can divide by 2. We're going to complete the squares. We're going to add half of negative 4 squared. Makes 4. Similarly for y, half of 6 squared makes 9. We have to add the same thing to both sides. We've got perfect squares, so we have a circle centered at 2 minus 3, 0, with a radius of radical 14. Find the value such that this vector is unit vector. That's going to be magnitude 1. Square each component, add them together, take the square root. First step is we're going to square both sides. So we have simplified that fraction as 5/4 x squared. X squared must be 4/5. So x is positive or negative 2 over root 5. U and v are 3D vectors. How many of these are valid? The magnitude must be positive. That's true. The sum of two vectors' magnitude is equal to the sum of their magnitudes separately. Not necessarily. Imagine if u and v were opposites. They'd cancel to 0, even if their own magnitudes weren't 0. Taking the cross product in different order reverses sign. Yeah, that's true. Dot product is commutative. That's true. But fifth, u dot v should equal magnitude u, magnitude v, cosine theta. It's actually magnitude of u cross v equals magnitude u, magnitude v, cosine theta. So just these three. The cross product of these two vectors is this determinant. Main diagonal product minus off diagonal product. 1 times 1 minus 0 times 0. Negative 2 times 1 minus 0 times 1. And 2 times 0 minus 1 times 1. C. Moving on to 5. The work done by pulling a sled 2 meters horizontally with a force of 5 newtons at an angle of 30 degrees. Work is force times distance times cosine angle. So we have 5 newtons times 2 meters times cosine 30 degrees, or pi over 6 radians. That's 10 newton meters times root 3 over 2. 10 over 2 makes 5. And a newton meter is a joule. A. Find the value of x such that these vectors are orthogonal. That's a 0 dot product. 1 times 2 is 2. X times negative 1 is negative x. 0 times 2 is 0. And this dot product should equal 0. So x should be 2. For number 7, the area between two parabolas, x equals y squared looks like that. 8 minus y squared looks like that. Parabola opening to the left. We have to find their intersection by saying, when does y squared equal 8 minus y squared? Or 2y squared equals 8, y squared equals 4, y equals plus or minus 2. So these are these points. And that gives us the integral of y from negative 2 to 2 of the right curve, 8 minus y squared, minus the left curve. This is going to be the power rule. 8y minus 2y squared integrates to minus 2y cubed over 3. Evaluate upper limit 2, so 16 minus 16 thirds. Then negative 16 minus negative 16 thirds. That's 32 thirds. Minus negative 32 thirds is 64 thirds, B. Find the volume of the solid whose base is the region bounded by y equal x squared, the x-axis, x equal 2, and whose cross-sections are squares. That's the integral from 0 to 2 of a shape that has a square base of x squared and then a height also of x squared. So we'll do the integral from 0 to 2 of x to the 4th dx. That's x to the 5th over 5 by the power rule. Plug in 2, that's 32 fifths, C. Number 9, find the volume of the solid obtained by rotating the region bounded by x equals 0, y equals 0, y equals 1/2, and natural log x about the y-axis. So these have intersections at 1, 0. We need 1/2 to equal natural log x. So x would be e to the 1/2 and y would be 1/2. We're going to use the washer or disk method with horizontal radius and vertical thickness. So y goes from 0 to 1/2. And the radius is actually from the left 0 to the right x, and we're going to have to solve y equals natural log x for x. So take the exponential both sides. E to the y equals e to the natural log x. So x is e to the y. That's our radius. Well, let's use rules of exponentials, or just multiply e to the y times e to the y is e to the 2y. Take the exponential integral, e to the 2y over 2. Evaluate first at 1/2. E to the 2 times 1/2 is e to the 1 minus e to the 2 times 0. E to the 0 is 1. And that's B. Find the surface area of the region rotating y equals x cubed about the x-axis. So rotating that about the x-axis. That's going to be a surface area of 2 pi integral from 0 to 1 of the height of the surface, x squared, times its distance formula, 1 plus the derivative of y equals x cubed is 3x squared squared. And this is going to be a u substitution. We're going to have square root of 1 plus 9x fourth. And this will be our u. And this will be the du. Those are third powers. 1 over 36 du. We have 2 pi. If x went from 0 to 1, then 1 plus 9x fourth will go from 1 plus 9 times 0 fourth is 1 to 1 plus 9 times 1 to the fourth is 10. And we have u to the 1/2 times du over 36. Okay, power rule there. 2 pi over 36 times u to the 1/2 power rule. Go up a power to 3/2. Divide by 3/2 or multiply by 2/3. And then evaluate from 1 to 10. We're going to plug in those limits and simplify as, let's see, 4 over 36 makes a 9th. 9 times 3 is a 27th fraction. Then we have 10 to the 3/2 minus 1. That's A. Number 11, find the volume of the solid obtained by rotating the region y equals x squared and y equals x about the line x equals 3. So there's x. There's x squared. We know they intersect at 1, 1. But we're going to rotate them around x equals 3. So we have to use the cylindrical shells method. And the volume would be the integral of 2 pi r h dr. So let's recopy the 2 pi constant multiple in front and say that our radius is from the current x value to 3. That's a final minus initial of 3 minus x. And then our height is the top graph, the line, minus the bottom curve, the parabola, x minus x squared. And the shells have thickness, left to right, horizontal thickness, and x goes from 0 to 1. And then if we were to calculate that integral, we just distribute through and do a few power rules. 12. If the work needed to stretch a spring 2 feet beyond its natural length is 8 foot-pounds, we could solve for the spring constant. K is F over delta X. That's 8 foot-pounds over 2 feet. That's a spring constant of 4. And the work needed to stretch a spring 6 inches beyond its natural length. That's the integral from 0 to 6 inches is half a foot of kx dx. So this will be 4, which was k, times x squared over 2 from 0 to 1/2. 2 times 1/2 squared is 2 over 4, or 1/2 foot-pounds of work, E.